The quadratic formula is derived from completing the square of the general quadratic equation. Completing the square is yet another way to solve quadratic equations, but we only solve quadratic equations in this way, if the exam question explicitly states so. In other words, unless the exam question says, solve by completing the square, then we will solve quadratic equations, either by factorizing the quadratic, if the quadratic is factorizable, or by using the quadratic formula, if the quadratic cannot be factorized. The general form of a quadratic equation is given by ax squared plus bx plus c equals 0. To complete the square, we proceed as follows. First, ensure that the coefficient of the squared term is 1. If it isn't, then divide each term by the coefficient of the squared term. The coefficient of the squared term, of the general quadratic equation, is a. Thus, we will divide each term by a. Ax squared divided by a, equals x squared. Bx divided by a, equals bx over a. And c divided by a, equals c over a. Of course, 0 divided by any number, equals 0. We now have x squared plus bx over a, plus c over a, equals 0. Next, we add a bracket squared, on either side of the equation. But, before we do that, we will move the constant term, which in this case is c over a, to the other side of the equation. We now add a bracket squared, to either side of the equation. Inside these brackets, we place half the coefficient of the middle term, of the quadratic equation. The coefficient of the middle term is b over a. Half of b over a equals b over 2a. So, b over 2a gets placed in each of these brackets. The terms on the left-hand side of the equation will form a perfect square trinomial. So, open up a set of brackets, and square it. Inside these brackets, place, as the first term of the brackets, the square root of the first term of the quadratic equation. The square root of x squared is x, so we place x inside the brackets. Likewise, place the square root of the last term of the quadratic, as the last term inside the brackets. The square root of b over 2a, all squared, equals b over 2a. Finally, place the sign of the middle term, which in this case is a plus, between the two terms inside the brackets. Next, simplify the right-hand side of the equation. Squaring out the brackets, we get minus c over a, plus b squared over 4a squared. Finding an LCM, that simplifies as minus 4ac plus b squared, all over 4a squared. We can rearrange that as b squared minus 4ac, all over 4a squared. In order to solve for x, we now need to square root both sides of the equation. The square root of x plus b over 2a, all squared, equals x plus b over 2a. When square rooting the right-hand side, ensure that you place a plus minus sign in front of the square root bracket. The plus minus sign in front of the square root bracket indicates that the quadratic equation has, at most, two solutions. Now, we cannot take the square root of b squared minus 4ac, because of the minus sign between the two terms. We can, however, square root 4a squared, since it is a single term. The square root of 4a squared is 2a. Thus, on the right-hand side, we now have plus minus root b squared minus 4ac, all over 2a. We now move the term b over 2a over to the right-hand side, in order to isolate the variable we are solving for, which in this case is x. Rearranging the terms on the right, and expressing as a single fraction, we get x equals minus b plus minus root b squared minus 4ac, all over 2a, which is the quadratic formula. To illustrate completing the square, we will again use the quadratic, x squared plus 5x plus 4 equals 0. When completing the square, we must first ensure that the coefficient of the x squared term is 1, which it is. Next, we move the constant term over to the right-hand side of the equation. We then add a bracket squared to both sides of the equation. Inside the brackets, we place half the coefficient of the middle term of the quadratic. The coefficient of the middle term, 5x, is 5. Thus, we place 5 over 2 into the brackets. The three terms on the left-hand side of the equation form a perfect square trinomial. The square root of x squared is x. The square root of 5 over 2, all squared, is 5 over 2. And we place a plus sign between the two terms in the brackets, since this is the sign of the middle term of the quadratic. On the right-hand side of the equation, 5 over 2, all squared, equals 25 over 4. Simplifying further on the right, we get 9 over 4. In order to isolate x, we now square root both sides of the equation. The square root of x plus 5 over 2, all squared, equals x plus 5 over 2. The square root of 9 over 4, equals, plus or minus 3, over 2. We now take 5 over 2, over to the right, to get x on its own. And since the terms on the right have equal denominators, we can simply add the numerators, to get x equals plus or minus 3, minus 5, all over 2. The solution to this quadratic is therefore x equals plus 3 minus 5, all over 2, or x equals minus 3 minus 5, all over 2. Therefore, x equals minus 1, or x equals minus 4. Complete the square for the quadratic, 2x squared minus 3x minus 7, equals 0. Since the coefficient of the x squared term is not 1, we need to divide each term by the coefficient of x squared, which is 2. Thus, x squared minus 3x over 2 minus 7 over 2, equals 0. We now take minus 7 over 2 to the right. Next, we add a bracket squared to both sides of the equation. The coefficient of the middle term is minus 3 over 2. So we half this, and place the result, which is 3 over 4, inside the brackets. Note that we can ignore the sign inside the brackets, since the bracket is squared, and is therefore always positive. The three terms on the left form a perfect square trinomial, so we open up a set of brackets squared and place the square root of the first and last terms, along with the sign of the middle term, inside this set of brackets. The right-hand side simplifies as 65 over 16. Now, to isolate x, we square root both sides of the equation. The square root of x minus 3 over 4, all squared, equals x minus 3 over 4. The square root of 65 over 16, equals, plus or minus, root 65 over 16. 65 does not have a perfect square root, but 16 does, so, root 65 over 16, equals, root 65 over 4. We now take minus 3 over 4, to the right to give us, x equals, plus or minus root 65 over 4, plus 3 over 4. We can express these fractions as a single fraction, as, plus or minus root 65, plus 3, all over 4. Rearranging that, gives us the solution, x equals 3 plus or minus root 65, all over 4.